In this mini lecture, we're going to look at equations that are quadratic in form. So we know a quadratic equation in standard form to look like this. Ax squared plus bx plus c is equal to 0, where everything is on one side of the equal sign and zeros on the other side. So it's a quadratic equation because its largest exponent is a 2, and that makes it quadratic, a second degree equation. Alright, so let's take a look at some examples. So our first example looks like this: x to the fourth minus 13x squared plus 36 equals 0. Alright, you already see that the largest exponent is a 4, right? Therefore it's not quadratic. To be quadratic, the largest exponent would be a 2. It's a 4. That middle term has a 2 as its exponent, and then we have a constant. So this would be quadratic in form. In form. It's not quadratic, but it's quadratic in form. And we can relate it to these other three terms above. The first thing we need to do is go ahead and make some type of substitution for the x squared term, right? So this will make sense once we write it down. I'm going to say let's let just some arbitrary variable. I'll just use the letter u. Let's let u be equal to x to the second power. If you think about that, if u is equal to x to the second power, then when we rewrite this, this will be negative 13u, right? So that's part of what we want, because if we look at the middle term of a quadratic equation, we have bx, the coefficient, and then the variable. The variable is raised to the first power. So u would be to the first power if this were negative 13u. And then if we were to square the u, that means you're squaring x squared. Well, when you square x squared, meaning when you raise x squared to the second power, it will become x to the fourth, right? So let's rewrite this. So u to the second power. Since u is already x to the second power, that's what we initialized, then u to the second power is x squared to the second power. When you raise a power to a power, you multiply, and we would get x to the fourth. So instead of x to the fourth, we write u squared minus 13. Instead of x squared, we're saying u is x to the second, 13u, plus the 36, that constant comes along, equals 0. And now this looks much more familiar. It's actually now in quadratic form, right? So to solve a quadratic equation, we can solve several ways. I think I'm going to go ahead and solve this by factoring. We can solve it by factoring, completing the square root property, or using the quadratic formula if we chose to. I'm just going to go ahead and do factoring. Since the leading coefficient is a 1, right, then I can just use that product sum method for factoring. If you need a review on factoring, feel free to go back earlier in the playlist, and we have some videos on factoring. So here I'll say to myself, what times what gets me 36? And those same two numbers, will they add or subtract to make 13? So I would say 9 and 4, right? 9 and 4 make 36 when I multiply, and if I add them, they'll get me a 13. However, I just need to get my signs right. It has to be a negative 9 and a negative 4, right? Negative 9 times a negative 4 makes a positive 36, and negative 9 added to a negative 4 makes a negative 13, which is what we wanted. So your signs are key in this one as well when you're solving by factoring. The next step is to use the zero factor property, or zero product principle. So we say u minus 9 equals 0, and u minus 4 equals 0. And then we just go ahead and solve each one of these for u. So add 9 to both sides, u is equal to 9. Add 4 to both sides, u is equal to 4. Alright, the next thing we want to do here is just go ahead and sub x squared back for u. right? Because we've solved for u. Our original problem had x's in them, and we had substituted u for x squared. So we're going to substitute x squared back in for u. So instead of u equals 9, we'll say x squared equals 9. Instead of u equals 4, we substitute the x squared back for u. X squared equals 4. Well, to me, and I'm sure for you too, you're looking at this and you're saying, okay, I can just go ahead and use the square root property to solve these two, right? Taking the square root of both sides, you'll get x is equal to plus or minus the square root of 9 is 3. X is equal to the square root of 4 is plus or minus 2. And remember, when we take square roots, now we take the plus and minus roots, right? Why is that? Because positive 3 times positive 3 will get you this positive 9, as will negative 3 times a negative 3 will also get you positive 9. Same thing for the positive plus and minus 2. Alright, so these are the solutions. We have 4 solutions: positive 3, negative 3, positive 2, negative 2 for x. We go back up to the original. The largest exponent was a 4, so that lets us know that we would have to have 4 solutions, as we did. Alright, let's go ahead and try another one. The second problem, we'll make it look a little bit different. A to the negative second minus a to the negative first minus 6 equals 0. Okay, a little bit more funny, right, because of these negative exponents. Alright, let's not let that worry us any more than it has to. So let's let u equal a to the negative 1. And again, I'm just using u. You can use any letter you want. You can use k, a y, or anything you want. So I'm just going to let u equal a to the negative first power, right? Because once I do that substitution, it's just going to be saying minus u. And that's what I want. I just want that middle term, that variable term, to be raised to the first power. So I can go ahead and say, just to clarify that a little bit better, u squared is going to be what? So if I say u is a to the negative first power, what about when I say u squared? Well, all that does is raise a to the negative first power to the second power, right? So that basically says a to the negative first power, raising it to the second. So that gets us a to the negative second. Alright, and we see that that's our first term. So let's go ahead and make our substitution. So instead of writing a to the negative second, we're going to write u to the second. U to the second. Instead of writing a to the negative first, we're just going to write this u here. And then minus 6 equals 0. This is much better now. Now it's just a quadratic equation that we can deal with. And again, here I'm going to just go ahead and solve this by factoring. Right? So I'm saying what times what makes 6, and those same two numbers have to add up to make this negative 1 that's in front of the u. So what times what makes 6? Okay, we would think 6 times 1. 6 times 1 makes 6, but if we add or subtract 6 and 1, we won't get this negative 1 here. So I would try two other factors. Let's try 3 and 2. 3 times 2 is 6, and 3 and 2, if we add or subtract, will get us this negative 1. We have to get our signs right. It would have to be a negative 3 and a positive 2, right? Negative 3 plus 2 would make a negative 1. And negative 3 times a positive 2 gets us the negative 6. So that works out. Now we use the 0 factor property. So u minus 3 equals 0, and u plus 2 equals 0. Go ahead and solve for u. U is equal to 3, and u is equal to negative 2. And now remember, we're just going to go ahead and sub, right, that a to the negative first power back into u. Alright, so we see u is equal to 3, but we're going to make it a to the negative first power is equal to 3, right? We're going to substitute back in. And u equals negative 2, but that's going to be a to the negative first power equals negative 2. Alright, so let's keep on moving. If I have a to the negative first power is equal to 3, I really don't like that negative exponent there, so I'm going to raise this entire term to the negative first power. So what happens when I raise a power to a power? Well, I have to multiply. According to the properties of exponents, I multiply, and what do I get? I get a to the first power, right? Negative 1 times negative 1 is positive 1, and you know and I know that I can write a to the positive 1 power, or I can just write a. And also what I did to that side, raising it to the negative first power, I have to do the same thing to this side. Alright, so we get a is equal to 3 to the negative first power. Alright, and then lastly, we'll say that we don't like that negative exponent, so according to properties of exponents, we'll move it down into the denominator where it becomes 3 to the positive first power, and 3 to the positive first power is just 3. Alright, so same situation over here for the a to the negative first power equals negative 2. I'm just going to raise this side to the negative first power, right? And then that's going to give me a to the positive first power. So what I did to the left hand side, I had to do to the right hand side. Raise this side to the negative first power. So I get negative 2 to the negative first power. Well, I don't really like that negative exponent, so according to properties of exponents, I'm going to move the 2 down to the denominator. Alright, move it down to the denominator, and it becomes 2 to the positive first power, which is just 2. So a is equal to 1/3, and a is equal to negative 1/2. Alright, we go to a third example. So this example says 3 times the quantity of y minus 7 squared minus 2 times y minus 7 minus 5 equals 0. Alright, so for this one, it's quadratic in form because we have something squared and then some term in the middle here, minus 5. So we can take these y minus 7s and let u equal the y minus 7. So let's do that. Let u equal y minus 7. Alright. So once we do that, we'll have 3u to the second minus 2u minus 5 equals 0. And now it's a quadratic equation that we're familiar with that we can solve. I'm going to solve this by factoring as well. This factoring is a little bit more tedious, a little bit more, only because of that 3, that leading coefficient. But you can either perform the AC method, which is in a previous video in factoring earlier in the playlist, or you can use the trial and error method, which I like to use sometimes too. So here I'm going to place in a negative 5 and a positive 1 because they work. Negative 5 times 1 makes negative 5. And in this one, because of this leading coefficient being a 3, I have a 3u and a u to make 3u squared. But the 3u times this 1 is 3u, and negative 5 times u is negative 5u. Well, negative 5u plus a 3u gets us the negative 2u. Alright, so then we go ahead and say 3u minus 5 equals 0, and u plus 1 equals 0. Alright, we go ahead and solve, and we get u is equal to 5/3. I may have skipped that step, but what did I do here? I added 5 to both sides, right? And then I divided both sides by 3 afterwards. Okay, and here I'm going to subtract 1 from both sides, so u is equal to -1. And then lastly, go ahead and we'll sub that y minus 7 back for u. Alright, y minus 7 back for u. So y minus 7 equals 5/3. Y minus 7 equals -1. Alright, so here it's just a matter of going ahead and solving for y. We're going to add 7 to both sides. We have 5/3 plus 7. So let's do that on the side. 5/3 plus 7. Just like 7 over 1, right? I believe the LCD of 3 and 1 is 3. This one will stay the same since it has the same LCD. 1 goes into 3 3 times. 3 times 7 is 21. Plus that 5 is 26/3. So y is equal to 26/3. And on this one, we'll just add 7 to both sides. So y is equal to 6. So we have our solutions of y equals 26/3 and y is equal to 6. So all of those were examples of equations that were quadratic in form. They weren't exactly quadratic equations, but they were quadratic in form. So we did some substitution to make it more make it more like a quadratic equation, and then we went ahead and solved it, and then came back and substituted back in. All right. Okay, so if that helped you any, please be sure to hit the like button. Feel free to share with your friends, family members, or classmates. Hit the subscribe button so you can get updates on new videos. And if you ever want something that's not in any one of the playlists, feel free to shoot an email to me and I'll get it up. All right, take care.